Hello, this is Kedrelitics. Welcome to today's session. In today's brief video, we're taking a look at Whitney U Test. We will demonstrate this using JASP, and as we do, we'll come to appreciate its application when it comes to research. Well, have you taken time to watch the video normality testing on this channel? Well, if you haven't, we encourage you highly to watch that video because it will give you a fair idea of what we are going to discuss in this particular video. Now, Whitney U Test, what is it all about? Well, it is the non-parametric equivalent of independent sample t-test. Well, what does it mean, non-parametric? Well, if you watch the normality testing video, you would have a detailed explanation to what it means data to be non-parametric. Now, have you also watched the video on the independent sample t-test? Well, that video would help you in juxtaposition with this to see the differences and the similarities between the independent sample t-test and the Whitney U test. But one difference is that while the Whitney U test focuses on non-parametric variables, the independent sample t-test is carried out on parametric variables. Now, one similarity between the two is that they all compare whether or not there is a difference in the dependent variable for two independent groups. Now, how is this test statistics calculated? Well, the test ranks all the dependent variables, i.e. least value, get a score of 1, and then uses the sum of the ranks of each group in the calculation of the test statistics. So basically, this is how Whitney U test is calculated. Now, having established this theoretical basis for the Whitney test, we will now want to dive into the JASP platform and see how we can demonstrate this practically. Good, so now we are on the JASP platform. So we'll click here, open, and then we'll go to recent file, and then we upload our data. So you can equally load any data that you have. Now, this data is the height of a population made up of males and females. Now, I want to see whether there is a difference in the height between the males and then the females. Now, so we select the independent sample t-test. Now, first of all, we want to make sure that our assumptions are met, whether we'll go for Whitney or we'll go for sample t-test. So we check for the assumptions, and then the assumption test. First of all, we load our variables, and then, yeah, we're waiting for that to load. Patient with it, good. Now, it tells us that our assumption test of normality, is significant. Significant results suggest a deviation from normality. So this is not normally distributed or parametric. Hence, we'll go for Whitney test, since we said it is the non-parametric version of the independent sample t-test. So we uncheck this and rather check this. Now, you realize that the alternative hypothesis here is that the group 1 is not equal to group 2. Now, the hypothesis for the Whitney test is that the median of both populations or both groups, male and female, are the same. And so the alternative is that they are not the same. And when we test this height, we realize that it is actually not the same. It's significantly different. So we accept the alternative hypothesis, and then we reject the null hypothesis. Now we'll do a descriptive statistics to be able to look at how the height and then the female height also they're also fair. And so when we look at the statistics, looking at median, not mean. So we can check that and realize that the females were having a higher median than the males. So it is not the same. So basically, this is how we can calculate Whitney test. You just check the student t-test, and then you check the Whitney test. You also check to see if your normality assumptions are all met. And when they are met, you go ahead. Until we meet again, This is Catalytics. It's a bye.